Hi everyone. This question has been taken from Olympiad Pathfinder, multiple choice question number 13 from chapter 12. Question is a half cylinder of radius r and length L, which is much greater than r, is formed by cutting a cylindrical pipe made of an insulating material along a plane containing its axis. The rectangular base of the half cylinder is closed by a dielectric plate of length of L and width 2r. A charge capital Q on the half cylinder and a charge Q on the dielectric plate are uniformly sprinkled. Electrostatic force between the plate and the half cylinder is closest to. So we have to find out from the choices which one is correct. Let us work on this problem. So this is the half cylinder which is made up of insulating material, and this is the dielectric plate covering the half cut section of the cylinder. In the question given, L is much greater than R, and this rectangular plate has the width 2R. Q is the charge capital Q is the charge uniformly sprinkled on half cylinder, and small q is the charge uniformly sprinkled on the dielectric plate that has been shown here. What to find is electrostatic force F between the plate and the half cylinder. Now, from the charge symmetry on half cylinder and L being much greater than R, capital R, the electric field on plate due to it will be in the x direction and uniform. This can be understood in one of the way by below figure, the top view. If you are looking from the top, we have taken x-axis in this direction, y-axis in this direction, and z-axis in this direction for the convenience. Now if we see from the top, we can see this section, because all the cross section will be like this of the half cylinder. Now if we say that electric field on the plate due to half cylinder is also having the components in the y and z direction, then in that case the charge which was on the dielectric plate should have been shifted towards the edges of the plate. But this is not the case here. In the question, it is given that the charge small q has been sprinkled uniformly on the dielectric plate. So it means y-axis, along the y-axis and z-axis, the component of electric field due to the half cylinder on plate will be 0. So all the components of electric field will only be in the x direction. This is one of the way. Other way is also by which it can be understood. The dielectric plate is lying in y and z plane, so that has been shown here. If we take a strip of dielectric plate and assume that dq is the charge on it, and we calculate the force due to the electric field which has been present there because of the half cylinder, so we can write df will be equal to dq into ex. It's a simple equation. Further, the dq will be, suppose sigma be the charge density on the plate, so sigma into this area, this dA area, small area, will be equal to dq. Now if we see ex into dA, this is nothing but it is a flux, field line flux, electric field line flux passing through the plate, dielectric plate. So this we can represent as d phi p subscript p. So upon integrating both sides, we will get F is equal to phi p is the flux passing through the plate, and sigma we can convert it to total charge on it is small q divided by the area of it. So area is 2r into L. So you will reach to an equation number 1. Now if we take infinitesimally small section of charge dq on the half cylinder, and focus on the field lines coming out of it, we know that any positive point charge emanates field lines spherically outwards in 360 degree. So it will be having the electric field lines in all directions in 360 degree solid angle. But the coverage of the field lines by this plate will be this much only, means whatever the field lines which the dq is emanating, only this, the field line which is lying inside or just on the edge of it, will be passing through the plate. But we know this is the half cylinder, so this angle will, so this is the diameter of that circular section, so this angle will always be 90 degree for all the points, because diameter subtends an angle 90 degree if we connect it from end to that point on the arc on the circle. So it subtends a 90 degree angle. So this angle will be 90 degree. By geometry we know this. But this charge dq is emanating field lines in all 360 degree direction. And 90 degree is 1/4 of 360 degrees. So only 1/4 of the lines will be passing through the plate. So phi subscript p means flux passing through p will be 1/4 of the total flux that it will dq will generate. By Gauss's law, we know d phi will be dq if dq is the charge within this by epsilon naught. So d phi will be dq by epsilon naught. We will integrate both sides. So phi will be dq is the, if we integrate, we will get the total charge on the half cylinder, that is capital Q by epsilon naught. We have already established that phi p is equal to phi by 4. So this will be equal to Q by 4 epsilon naught. So from equation 1 and 2, we will get force is equal to Q, small q into capital Q divided by 8 epsilon naught L into R. So answer will be D from the options, because D is having the same value as this. In case anywhere you have problem in understanding, please comment in the comment box and be specific where did you face the problem so I can explain again. Thank you.